Hello, I'm Bob Glithero, Senior Product Marketing Manager at VMware. In this video, we're going to show you a demonstration of data management for VMware Tanzu. We're going to show you how it simplifies the lifecycle management of data services running on vSphere platforms to deliver a better experience for both database administrators as well as developers. At VMware, we talk a lot about application transformation, but it's more than just about tooling and technology. It's about delivering the best possible developer experience. And unfortunately, archaic ways of database provisioning, of lifecycle management, using configuration management tools, using scripts for automation that are brittle and difficult to maintain, get in the way of the agility and speed that developers really want. Requesting new databases involves a lot of lost time coordinating amongst various teams and stakeholders. There's multiple planning sessions, review sessions, approval gates that have to be gone through. There are lots and lots of meetings and emails and document exchanges. It's a slow, drawn-out process. So some weeks or months after submitting a request, the development team finally gets a database that they can begin to develop against. So how can we improve this process? Data management for Tanzu is designed to provide a better experience both for the database administrator as well as the developer. It automates away a lot of the tedious work involved in managing databases, whether that's backup and recovery, security, patching, and other routine maintenance operations, so that database administrators can focus on higher value work and developers can get the database services they want on demand with as little friction as possible. Data management for Tanzu is designed to fit well in developer workflows with support for REST APIs, and it helps database administrators ensure the customer data is always running in approved, validated database instances that conform to enterprise policies. And it also automates away a lot of the lifecycle management work, whether that's creating replicas or backups, automating maintenance windows, patching and upgrades, as well as providing extensive monitoring support for health and performance. So in this demo, you're going to learn how to create a database from scratch. You'll learn how to set the infrastructure resource levels, how to assign a database to a deployment target, whether that's local or in the cloud, how to create replicas and backups with point and click ease, how to set maintenance schedules, and to monitor the database and virtual machine health and performance. So with that said, let's launch into our demo.
So the UI that I'm showing here is the single DMS UI that's used by all users. So that would be database users or the administrators that are managing the system. As we mentioned in the slide deck, the same endpoint has an API endpoint integrated into it, which is an open API compliant API, so that you can fully automate everything we show today could be driven from using the API. So DMS has three different personas, and I'm going to show them, I'm going to describe them, and then we'll go through them. So the first one is really an org user. That would be a developer or someone that's creating the database and using the database. So that's the low-level user. Then above that user, there's an organization administrator. So in DMS, we can group users and assign users into organizations and then assign them to share infrastructure. So an org admin is someone who manages a group of users, defines which services and database types those users can use, and generally takes care of the infrastructure that those databases are hosted on. And then the last persona is a provider. The provider is the service operator. So you can think of that as a cloud operator. They're the person that's running the DMS service, or the DBAS, and they are responsible for operating the entire environment. So I'm going to show you these personas in the order that I've described them. First, we're going to start as a DB user, see what the end user experience looks like. Then we'll take a look at the provider. So first, let me just log in. So first thing you'll notice here is that I'm allowed to choose an organization. So as a user, I can belong to more than one organization, but in this case, I just belong to one. But if I were a member of more than one, I could pick one here, or I could change it once I've logged in. When I log in, this is a view I see. I get this dashboard view that shows me how many databases I've created. I have 17 out there, how much storage is available, how many backups have been taken of these databases, the distribution of database engines, how my storage is broken down, so that would be for local storage and cloud storage, and my total capacity available. So for most users, they're going to spend their time over here just clicking this database tab. It'll show them all the databases that they've created, and they can click through. And I'm going to jump right to how do we create a database, because that's the most important thing. So on the upper right, you click this Create Database button. And here I can pick in 1.0, I can pick from these two database products, Postgres or MySQL. I pick this, I can name my database anything I want. I'm just going to call it my test Postgres. And then I select a version that I want. So I'm going to pick 12.7.0. This environment tab would allow me to pick multiple places where I could deploy this. As a user, in this case, I really only have a single environment. The DMS could be configured so that I had a choice of places, and they may be, those environments might be distributed, geographically distributed, or they may have different capabilities, such as performance or maybe different levels of encryption and security in those environments. But in this example, I just have one. So I can then just click this Create DB with default configuration, and it's started. So that's the fastest way I can create a database. I've accepted all the defaults. See a message saying that DB creation's in process. And if I come down here, I can click this running taskbar, and it'll show me that there's a Create DB. So this is a history of all the different operations I've been performing as a user. I can see that this is underway. I can also go back here, I can pick it here. And there's very detailed operations audit log that's presented. So in this case, all that has been sent down so far is a create database message that was sent from the provider to the agent running on that remote infrastructure. If I click on this, it'll show me a detailed audit trail of the steps and progress underway as this gets deployed. So this will probably take about 90 seconds for this database to be provisioned. Well, in the meantime, I'm going to pick one of the existing databases and show you some of the other features. So let's just start by picking, let's say, this database. So this is the detail page that I can see. I can see a lot of information. So I can see the database name that I chose was Acme1. I can see that it's a primary database, not a replica. And I see these two different IPs, and I see an FQDN. So this is how I can access this database, either by FQDN or by the database IP. I see other things like the time zone, max connection, some of the other settings on the database. And at the bottom, I can see if I have replicas for this database, where those replicas are and what their states are. So for every database that's already deployed, I have a variety of options I can perform. So over on the right, you'll notice database actions. So I can power this database on, power it off, or I could delete it. I could also clone it. So the clone operation would make an exact duplicate of this database with all the data as it stands at this point in time. And then I'd have two databases, and they would both be backed up. So let me show you quickly how I could connect to this. So this IP I'll use, I can come to any kind of product. Here's DB Beaver. So if I go in, let's see, and say edit connection, I put in my IP, and I say connect. Let's see, did that connection. Put my password in. And I set when I created it. That's my connection. Okay, so I'm connected. So then at this point I can go in and perform any operations I normally would. What I have is a slightly reduced admin. So I can create tables, I can do a lot of full capabilities, but I can't do absolutely everything. So this here I can just see some tables I've created, and I could just do my job now that I have my database in place. Okay, so next thing to show you is let's take a look at monitoring. So for this database, I can go to the Monitoring tab. Here I'll see any alerts or things that have happened historically for this database. And these columns will show me the status of different things, whether I'm in normal status, warning status, or critical status. This is just a bird's eye view of the database health. I can also go into DB metrics. So in the DB metrics, I'll see a variety of different things, starting with database details such as active connections per second, CPU usage, memory usage, disk usage. I can change the time frame here to see the duration that I want to see the data for. And I can see read and write performance, commits and rollbacks, deadlocks and conflicts. So this is the data that I can see. The provider can also drill into this data from a higher level and see the same data, and also can see it organized across the entire cloud service. But this level of detail is available for regular users. This is known as enhanced monitoring. When we look later about how to make a new database by specifying all the features, you'll see that I could have basic monitoring. So if I don't want this level of detail, I can get a much reduced view just showing me a high-level set of stats. Okay, let's go back again to databases and just show you one other function. So in this case, you'll see that this database is a primary. I pick this database and scroll down where I can see my replicas. I can click here and say create another read replica. So this allows me to create a synchronous read replica that I can name whatever I want, and I can then have the data replicated to multiple replicas. In this case, actually, you can see, just go back here, this database already has a read replica. So this is a read-write access endpoint, and this is a read-only access endpoint, and they're synchronized. If I go into this database, I can, this is the replica, I can do a promotion. So at this point, it would take my read-only replica and promote it to the master, and that would become my new endpoint. That was read-write. My DBF QDN would stay the same, and my applications would be able to connect to the new master. Okay, great. So let's talk about day two operations. So for any database, we were talking about the fact that there's some monotonous tasks that have to be done that nobody enjoys, and that's really where DMS provides automation capabilities. The first thing we'll talk about is backups. So in this case, when I create a database, I can schedule automated backups. These backups will happen every day, and I can automatically store them locally and in the cloud. So in this case, I've got 4 backups that have been completed. There was a full backup when the database was first created, and I've had 3 incremental backups since then. Each of these backups is available both locally on object storage within my data center, and also available in the cloud. And that might be something like off-premise S3 storage or Amazon storage. From any of these databases, the fully incremental, I can click on the right and do a restore or a point-in-time restore. So a restore is a full restore of the data from the point of this backup. So if I was same as here, this would be the full plus the incremental would be the point I was restoring to. I can also do a point-in-time restore. So this is where I have a choice. I can say I want to restore to the oldest available time, the latest available time, or a custom time. In this case, I can pick a point that's in between the beginning and the end of those backups, and I'll restore a brand new database. So this is really valuable for accidental data corruption, or maybe you realize at some point in time that something happened and you want to restore to just before that event. When I create this, I can also specify whether I want minor version upgrades and whether I want to enable a maintenance window. And we'll talk more about that in a minute when we look at how to create database through full specification. For any database I have, another thing I can do is if I go into VM settings, I can do things like change the compute configuration or extend the disk. So let's assume that I created this database, I used the default settings, and I now wish to change my CPU cores and memory. I can come in here, change, supply new values for these, and the database image will be, the database virtual machine will be resized to these new specifications. Similarly, I can go in and extend disk. So if I started out with a certain amount of disk, I can increase that disk and it'll take the database and extend the disk. It shows me here the available, I have 6.7 terabytes available, recommends that I don't use all 100% of it. And I can specify whether I'd like to take a backup before I do that extension. Okay, next let's take a look at, I think I already mentioned clone. So maybe it's time to switch, take a look at what a full database creation would look like. So in the beginning, you remember I created this my test Postgres database, and it's now online and available. So I'll just click on that. Here's the IP it got. There's the database that I created. What I want to do now is show you how I would create a database without trying to do it by accepting all the defaults. So I'll come back here and say another Postgres database. I'll make it let's click here. There you go. Right. So this time I'm not going to click the create database. I'm going to go into them setting by settings. So we talked earlier about the idea that a database administrator can create plans or preset values. If I was in an organization with preset values, these values would be set through a t-shirt size. So when I come into this page, it would say, would you like, for example, small, medium, or large? My DBA would have already specified the sizes of CPU, memory, and storage for each of those t-shirts. The organization that this user's in is called a free-form organization, and this user has the ability to set those values without doing t-shirts. So they can use a slider bar to select the sizes of the infrastructure. As we mentioned, in a lot of production environments, we expect that t-shirt sizes would be a more manageable choice to control infrastructure utilization. But once those are set, I can then click on Management Settings. Here I mentioned before you can have normal or enhanced monitoring. If I ask for enhanced monitoring, I'll get much more detail related to the debrief performance. Data protection is an option that I could say I don't want any backups. So perhaps I'm just going to create this database and play with it for a few hours. I don't want it backed up. I can uncheck this box. I can also check or uncheck auto minor version upgrades. So one of the tasks that's monotonous is upgrading databases. So in this case, I can specify a maintenance window, and the system will come and upgrade my Postgres or MySQL database whenever new minor versions are available. Under additional settings, I can do things like set the database name, change the database port number, set my username and password for the administrator. Again, that's a slightly reduced DB admin. I can select the data store if I had multiple, if my DBA had given me access to more than one environment. I could pick those environments. I can pick multiple data stores. In this case, I do have a choice. So, for example, one might be encrypted and the other is, in this case, this is encrypted storage. The other one is NFS storage. So I can pick the storage that matches my use case. And then I can, my VM network is the name of the network that my application database, my database will be advertised on that network so I can connect to it. Under the backup section, I have a choice of when I want the backups to run. So presumably I'll set these in the middle of the night when it won't be disrupting my other work. I can set my local and cloud retention periods. So the default is I would keep 7 days of backups on premise, and then the system would automatically run those following days up to 91 days up to Amazon S3 or other offsite cloud storage. And the next thing is the maintenance configuration. So in this case, when I talked about doing updates, I can set the day and time when I would like those updates to be run. So here I specify a maintenance window, and if there are updates available for that database, then the system will execute them within this maintenance window. TLS connection allows me to check or uncheck whether I want the database to have a TLS connection. If I select this, it'll generate certificates for the database. As a organization, I can upload my own root cert CA, so I can have my own customized certificates. And then depending on database type, I can set a number of database options. So in this case, most of these are unset, but I can override these as I see fit to customize my database. Finally, I get to the summary screen. I see a summary and I just hit create database. And now we're back to where we started. So we can see that a new database is being created. I can see that in the task window. In fact, let's go back for a second and take a look at one of the earlier databases. So this database that we created, my test Postgres, I showed you at that time under operations. I can see each of the activities, and I can drill into these and see details as to exactly when things were done. This is also available, this audit information is available to the provider who runs the service, so they can also track and troubleshoot operations. Okay, so now that's the view that a regular user, or in fact an admin or admin would see. What I wanted to show you next is what the persona looks like for the service provider. I'm going to log out, log in again. Now I've logged in as a provider. By default, I'm in the provider organization, but I could be in tenant organizations as well, and then I could switch between them. So it's a very similar looking screen. We just have some extra options down on the left nav. And in this section, what I'll do is talk about most of the setup and operational aspects of being a provider. So we'll start with the idea of templates that we talked about in the presentation. So for each of the databases that are available through DMS, those are available through a trusted repository that VMware hosts on TanzuNet. When we configure and initially install DMS, we put in an API token so that we can connect to that site. And the system pulls that site regularly and pulls down templates. So for each of these templates that's available, as a service provider, I can decide to publish them or unpublish them. So a new template that came down for perhaps an 8.1 MySQL, I could publish that or wait and not make it available to my organizations. I could also unpublish something. So if I have databases in flight and I've decided I don't really want more databases to be created, I can unpublish it so that it doesn't appear in the picker anymore when people are creating new databases. But we'll continue to maintain and patch the databases that are already in flight. The next thing I would do as a service provider, once I set up all these templates, is I decide who had access to them. So there's a concept of organizations. So as a provider, I might just create a single organization and put all my users in that organization, or I can create multiple organizations where each organization can have its own set of users and target its own specific infrastructure. So one of the first things that you would do in this case is set this up and specify users. So for example, if I take a look at this NASA account, look at users, I'll see there's two types of users typically. There's local users and there's also LDAP-based users. So we have the ability at each organization to retrieve members from groups within a defined LDAP configuration. So let's just quickly take a look at that. If I go over to settings and pick LDAP settings, here I can define at a high level the connection information to my Active Directory or other LDAP provider, and I can specify search filters and attributes that would take care of authentication. So this would set up a connection to LDAP at the corporate level and enable DMS to authorize users against this or validate users against this provider. Once this is configured, the next step is that in each organization, I can decide that each of these users might come from a different provider group. So I have the option to specify groups that are in my LDAP server. Any users that are in those groups would then become users that could log into this organization. Okay, the next thing I wanted to talk about is infrastructure. So now we have the databases from the templates. We have organizations with users. What we need next are places that we can host databases. So we mentioned earlier that the product uses agents for each piece of infrastructure where DMS will host databases. There's an agent which is onboarded when the product's installed. Once the infrastructure is what we call onboarded or registered, it shows up in this list. When I click on this list, I can see details about the cluster. So this would be in this case, a vSphere cluster that's in this data center. I can see the data stores that I have assigned, the networks that are assigned. I can see the local and cloud storage that's associated with this infrastructure. And at the bottom, I can see organizations that have been given permission to share this infrastructure. So as I mentioned earlier, you can onboard multiple clusters. I only have one in this case, and then assign individual organizations either to their own cluster or assign them to share a piece of infrastructure. Okay, we're moving along nicely. So now let's talk about storage settings. I mentioned in the beginning that when you first install the product, one of the things you set up, you deploy your provider, and then you set up storage for cloud backups and local backups. So there's a couple things we define in here when we first launch the product. We define what's called the provider repo URL. So this would be an S3 endpoint that my organization is providing or has contracted through a third party like AWS3. That's a bucket that I've created that will be used by, here's the bucket name, that will be used by DMS. I specify another bucket to hold logs and another bucket to hold provider backups. So the provider backups in this case are the service itself is being snapshotted and saved into a bucket so that if recovery is necessary, it can be restored from backup. The other thing we specify here is a Tanzu Net token. So a Tanzu Net token in this case is an API token that's associated with a user who has permissions to access Tanzu Net. The system uses this API token to retrieve the templates that we saw earlier. Those templates include the current databases and the database as versions as they're updated. The other third thing that's interesting to speak about here is I mentioned this provider backup. We support two different deployments for the provider. You can deploy the provider as a standalone VM. In that case, we'll take backups of it every 30 minutes and store those backups on S3. Or for production configurations, we recommend you do a high availability deployment. So in this case, we can add up to three of these providers operating in a cluster, and then I have the ability to monitor that and do a failover in the event of any kind of outage on my primary node. Okay. Let's see, next let's take a look at monitoring. I mentioned before that we have quite a bit of monitoring that we can see at the high level. But first I can see all the database operations that have been happening across users. I can look at the individual databases that are out there. I can see if there's any alerts that have come. So this view is really to allow me to manage a large number of databases as a homogeneous list. And I can also monitor my infrastructure in a similar way. So I can drill into this infrastructure and I can get information about databases. I can pick a host, for example, and it will show me the top 10 databases that are operating on that host in that infrastructure, show me the top 10 memory consumers. And then I can select individual databases if I would like, for example, here. And I'll get a lot of the information you saw before at the user level. So we can see network, CPU, and memory. And this would depend on the level of monitoring that the database had available